Okay, for day 3, the objectives can be a little confusing, so make sure you pay careful attention. We'll talk about increasing and decreasing, concavity, and behavior. Hopefully by the end of the lesson you'll know what those words mean. Absolute maximum or minimum value and how it relates to domain and range. And we talked about standard, we talked about vertex. The new one is going to be factored form. So increasing and decreasing have to do from left to right. So from left to right, from this portion, the graph is going down from negative infinity to whatever this x value is, and then from this x value up, it's going up. So the green is increasing, the red is decreasing. Now, if you look at this parabola as a cave, to get out of the cave, the bear has to go up. So the concavity is up. The lowest point in this parabola is the vertex, of course. That's where the minimum value occurs. A parabola will either have a lowest point or a highest point. And then the end behavior, x going to negative infinity means going to the left. Y going to infinity, that means up. X going to infinity, that means right. And y going to infinity again means up. Second graph is similar from left to right. It's going up. Then it makes a turn and it's going down. So in terms of increasing and decreasing, part of it goes up, part of it goes down. But in terms of concavity, here's the cave. To get out of the cave, the bear has to go down. The concavity is down. This time, going to the left, x goes to negative infinity, we're going down. Y goes to negative infinity. To the right, x is going to infinity, and the right side is also going down, and that's going to negative infinity. So left, right, up and down, increasing, decreasing, all these different directions. Make sure you know which goes with which. Now listen very carefully. We're finding the minimum and maximum values. It does not say point. True, there's a minimum here, but here's the idea. The minimum y value is the k value of the vertex, and where it is the x value. So the lowest the y goes is to this point here, and then the y values increase. Whereas here, the y values increase till we get to here, and then the y values decrease. And so in this case, we have a maximum. So the minimum maximum value occurs at k, the y coordinate of the vertex. I don't want the whole point, just the y value. So here is what I would suggest you do. Second degree, it's a parabola. The a value is positive, it goes up. Look at B. Second degree, it's a parabola. The a value is negative, it goes down. You should be able to start each of these off very simply. Okay? Then we just said that the minimum occurs at the vertex, or the maximum occurs at the vertex. So let's find the vertex. So negative b over 2a, finds us the x-coordinate of the vertex. And you're right, I made a mistake. A negative a half over a positive a half is negative 1. Let's now plug that into our equation correctly. We square negative 1, it's still positive, so this is okay. Now this is going to be a negative a half. And then we're still going to subtract 1. Since we want a common denominator, I made everything into fourths. So negative 1/4 minus 2/4 is negative 1/4, minus 4 more fourths is negative 5/4. So the y value of the vertex is negative 5/4. So the minimum value of the function is just the negative 5/4. Not the whole point, just the y value. Let's see if I did b correctly. Negative b over 2a, that's negative 6. Plug it in for the x value here and here. And we get 27. So, in this case, since the parabola is going down, we're going to get a maximum value of the function, meaning the highest y value that this parabola hits is going to be 27. Okay, for example 2, they want us to write the equation in vertex form first, and then give the domain and range. When it's increasing and decreasing, concave up or concave down, absolute value, absolute minimum or maximum value, and we write end behavior statements. So, here's our blank vertex form. They give us the vertex. I plug in the h and the k. Again, don't forget, subtraction is part of the formula, so subtracting a negative 1 is plus 1. Now, they give us the y-intercept of 6. What that is just some x and some y on the parabola. The y-intercept is on the parabola. And so I plug in 0 for x and 6 for y. So I plugged in h, k, x, and y. A is left behind. So I solve for a. 1 plus 0 is 1. Squared, it's still 1, so we just get a. And then to get a by itself, we subtract 8. And we get a is negative 2. We put in the h and the k. The x and the y go back to being variables because this y-intercept is only one of the points of the parabola. There are others. Since the a value is negative, the parabola goes down from the vertex. Domain for a parabola, if it's a function, always goes forever left and right. The range for the parabola goes from bottom up, so from negative infinity up to the y value of 8. It's increasing to the left of the vertex. It's decreasing to the right of the vertex from the x value. Again, increasing and decreasing are the x values, where it is increasing or decreasing. The y values are increasing or decreasing. The x values are where it happens. This time, we're going to start with the vertex form, the blank vertex form, with nothing filled in yet. We're given the vertex, hk, and now we're given a explicit point with the xy. We plug that in for the x and the y. So negative 1 minus 2 more is negative 3, squared is 9. We add 3 to both sides to get 1. We divide both sides by 9 to get 1/9. Our a value is positive, so the parabola goes up from the vertex, the domain left to right, the range from bottom to top, from the y value. It increases to the right of the vertex. It decreases from left to right to the left of the vertex. And here the cave is going up, and so the bear has to get out by going up.